The basic vector relationship that we have used in this relative velocity problem is velocity of wind relative to earth equals velocity of man relative to earth plus velocity of wind relative to man. It's a vector relationship that we have used. This vector relationship for the three cases is drawn in the same diagram. We have represented this vector relationship for the three cases mentioned. Same diagram we have drawn them. Now you study the diagram carefully, then we'll give you some explanation on it. The vector which remains constant in the three cases is the actual velocity vector of the wind, represented by AE, vector AE in the diagram. Because the wind velocity is independent of whether the man is moving fast or slow or remaining at rest. So man's movement has no effect on the wind velocity. Only the relative velocity, including direction of the wind, only will change if the man is moving. So, the first case, man moving with velocity v, is not enough for us to, that is, the vector diagram, vector triangle will not be enough for us to locate or fix E. So the second case, man moving with velocity 2v, is superposed on it. With that, we are able to fix E. When we fix E only, we will know the actual velocity vector AE. So that is, once E is fixed, the third case, that is the man moving with the 3v, is superposed. On the first three, we are superposing the third case to get the new apparent direction DE. DE is the final required direction of the apparent velocity of the wind in the third case, which we have marked as coming from N 64 degree east. That is 64 degree east of north. That is the meaning, coming from that direction. Conventionally, the directions are given in terms of angle made with the north or south. So that is the convention we have used to give that answer of north 64 degree east. Okay, I think now you can follow the solution given. Thanks.